Welcome to This Explainer. Today, we're going to completely flip how you look at the ground beneath your feet. For most of us, the stuff we walk on every single day is just dirt, right? It's just a silent, static backdrop to our lives. But today, we're transforming that view. We are going to uncover how the soil is actually this dynamic, high-performance, living engine that literally drives the Earth's most essential life support systems.
And to kick things off, let's start with a number that might absolutely blow your mind. To have a perfectly healthy, fully functioning subterranean ecosystem, exactly half of its volume needs to be absolutely nothing. That's right, 50% of healthy soil isn't solid matter at all.
Okay, let's dive into what that actually means and why this empty space is so critical. We call this the void space. This 50% threshold is designated entirely for air and water. You can kind of think of it as a high-speed highway running right through the soil matrix. Without this open porosity, the whole soil engine literally seizes up. That leads to anaerobic conditions, which is essentially a state of total biological stagnation. So, weirdly enough, this nothingness is actually one of the most important spaces in the world.
So, here is our roadmap for today's journey. We'll be exploring 1. The engine beneath our feet, 2. The 6 soil personalities, 3. The underground labor force, 4. The rhizosphere trading floor, and finally, 5. Coaching your living soil.
Let's start with Section 1, the engine beneath our feet. We really need to establish the geological DNA that builds the structural frame of this underground city.
Think of it as a perfect recipe with 4 key ingredients working in total synergy. You've got your mineral particles making up 45% of the mix. That's the sand, silt, and clay derived from weathered rocks, acting as the solid bones of the structure. Then, filling up that crucial void space we just talked about, you have 25% air providing vital oxygen for root respiration and 25% water acting as the universal solvent to deliver minerals. Finally, making up just 5% is organic matter or humus, and that acts as the biological glue holding the whole shebang together.
Moving on to Section 2, the 6 soil personalities. With that basic recipe understood, let's explore how the actual size of those solid mineral particles dictates the unique character of the landscape.
Nature really provides some extreme opposites here. On one side, we have sandy soil, which is kind of like the fast-paced traveler. Because it has large particles and wide gaps, water drains rapidly. Now that brings a high risk of desiccation or drying out, but this open-door policy means there's minimal resistance, allowing taproot-heavy crops like carrots to grow beautifully. On the flip side, we have clay soil, the stubborn guardian. It has incredibly fine, tightly packed particles. It is dense with nutrients for sure, but that tight packing creates huge mechanical resistance. That makes it really tough for roots to penetrate. And if you're a farmer, it significantly spikes your fuel costs and operational expenditures for your tractors just to till the land.
So, understanding these diverse profiles dictates whether water becomes a growth resource or a massive structural hazard. For example, loamy soil is perfectly balanced. It's the absolute gold standard for agriculture, basically no primary risks. Silty soil holds water moderately well but lacks structural grip, making it highly prone to erosion and topsoil loss. Then you have peaty soil, which acts like an ancient, slow-draining sponge with high organic acidity. And finally, chalky soil, which drains rapidly and struggles with high alkalinity thanks to all that calcium carbonate.
Now for Section 3, the underground labor force. Because, let's be honest, a city's physical structure is totally useless without its workers. Let's meet the biological inhabitants that prevent this asset from stagnating into dead dirt.
There is an incredibly diverse array of life actively breaking down matter and cycling nutrients right beneath our feet. This is the subterranean metropolis in action, and it's buzzing with activity. This biological workforce provides services that are literally as vital as synthetic fertilization. First up, microorganisms. These specialized bacteria are the only entities capable of pulling nitrogen directly from the air and fixing it into a consumable plant food. Then you have earthworms, our premier biological engineers. They burrow around creating ventilation shafts and processing organic matter into highly concentrated units of fertility called casts. Finally, your insects and arthropods. Ants, termites, beetles, they act as the primary movers, physically mixing the earth to maintain that precious 50% void space and prevent anaerobic failure.
Which brings us to Section 4, the rhizosphere trading floor. Let's see how all these workers build into an intricate, high-stakes subterranean economy.
We generally tend to think of plant roots as passive consumers, right? Just sort of sitting there drinking up whatever comes their way. But in reality, roots are active investors shaping the immediate area around them, a highly active zone we call the rhizosphere.
And the way they do this is through a highly sophisticated symbiotic trade. It's a true economy. Step 1. The roots secrete specialized plant-produced sugars right into the soil. Step 2. These sugars act as a lure to attract and essentially farm microbial partners. Step 3. In exchange for this sugary currency, the microbes provide the roots with essential minerals they've mined from the surrounding mineral particles. So the roots are literally purchasing nutrients. How cool is that?
But beyond participating in this brilliant economy, roots also act as the city's structural engineers. They physically bind the soil particles together, acting as a massive living net. This mechanical stabilization is the Earth's absolute primary biological defense. It holds the physical volume of the land asset securely in place against the destructive forces of wind and water.
Let's wrap things up with Section 5, Coaching Your Living Soil. Because how do we take all of this fascinating science and actually use it to actively optimize our land asset instead of just sitting back and watching it?
The trick is to think of yourself as a coach supporting your soil's specific strengths. Managing sandy soil, you'll want high-frequency, low-volume irrigation, and make sure to incorporate humus for extra grip. Dealing with clay, you need subsurface drainage and organic amendments to disrupt that really tight packing. For silty soil, permanent vegetative cover is simply mandatory to defend against erosion. And for peaty or chalky soils, well, it's all about chemistry. You're going to apply pH buffers for the peat's acidity or acidifying fertilizers to balance out the chalky alkalinity.
When we protect the ground, we are protecting a regulator of the Earth's most essential life support processes. The ultimate takeaway from our explainer today is that planetary vitality relies entirely on this synergy between physical architecture, hydrological dynamics, and biological labor. The soil isn't just a surface, it's a self-sustaining life support system. When you protect that 50% void space and support that underground workforce, you are ensuring the health of literally everything living above the surface.
So now that you've seen the hidden metropolis right under your shoes, I want to leave you with this question. Are you ready to stop just walking over the soil and start managing the engine of the world? How will you treat the ground differently tomorrow? The next time you step outside, I hope you remember the bustling economy, the biological engineers, and the delicate living net right beneath your feet. Thanks for joining me on this explainer, and keep exploring the amazing mechanics of our natural world.